Alright, this video is on triangles. So first we're going to talk about classifying triangles, okay? And when you classify a triangle, it gets two different names. It gets one that has to do with angles, okay? So you'd either call that acute, obtuse, or right, okay? And that doesn't mean all the angles have to be acute or all obtuse or all right. Acute it will be, but obtuse and right, only one of them can be. There's no way I can have an obtuse angle and then have another obtuse angle and have it be a triangle, right? I need another side at this point. That'd be four sides, right? So as soon as I make an obtuse angle, it needs to come back and have these two other acute. Same with right. As soon as I have a right angle, it needs to have two other acute angles, okay? So whenever we're talking about the angles, we're talking about the final third angle. Is the third angle still acute, or is it obtuse, or is it right, okay? And then sides, you can have scalene, which means all three are different. You can have isosceles, which means two are the same. Or you have equilateral, where all three are the same. Okay? So all triangles will have one angle name and one side name. Okay? So looking at our first triangle, triangle ABC, I have the measurements of all the sides over here. Okay? And as you can see, they're all a little bit different. So this is not equilateral, even though they look close to the same. Okay? So they're scalene. So it's a scalene triangle. And the angles are all acute. Like they're all little. They're all less than 90 degrees. So it's a scalene acute triangle. Our next triangle, KOL over here. Again, I measured the sides, and you notice two of the sides, this side and this side, are the same. Okay? And those little tick marks mean they're the same. They're congruent. They're equal. Okay? So that would make this isosceles. If two sides are the same, it's isosceles. Make sure you have that written down in your notes. And again, it's acute. All the angles are less than 90 degrees, right? Clearly less than 90 degrees, so I don't even need to measure them. All right, DEF up here, all the sides are clearly different, so it's definitely scalene. I don't even need to measure them, I know for sure. But then this angle down here, as I suspected, is obtuse. It's bigger than 90 degrees, so it's a scalene obtuse triangle. And our last triangle, all the sides, again, clearly different. So again, it's clearly a scalene. I don't even need to measure. But this angle right here, as I suspected, is 90 degrees. So it's a scalene right triangle. It has a right angle in it. Okay. So the only one we don't have up here is equilateral. Okay. And remember, equilateral, all three sides would be the same, and all the angles would be acute. Every equilateral has to have acute angles. Otherwise, it doesn't connect up properly. Okay. And we'll talk a little bit more about that in a minute. So there's our different types. Make sure you have a definition for each type of classification. Pictures and words are very helpful for your definitions, okay? All right, our next thing is talking about the angles of a triangle. So the most important thing before we get into this to know is that triangles' angles, okay, equal 180 degrees, okay? So all three angles always, no matter what, to be a triangle have to have 180 degrees. Well, that makes this problem a lot easier, right? If we know that this is 120, and we know this is 20, already that's 140, so that means we need 40 more degrees over here, okay? So it makes it a lot easier knowing a triangle's angles add up to 180. Note that in your notes. All right, so again, we know a triangle's angles equal 180, so triangle's angles add up to 180. And then this one, we only have one angle though, so we're missing two different ones, okay? So let's look at this question up here. It says, what type of triangle is this? Notice these two little tick marks. That means this is isosceles. So remember, isosceles triangles means these two sides are the same, okay? Well, what's interesting about isosceles triangles, if you go down these legs, these are called legs, to the base, these base angles are congruent. Base angles congruent. Remember, that's the congruent symbol, okay? So this is something else to add to our notes. Base angles of isosceles triangles are congruent, okay? So if those two are the same, if that's x, this is also x, okay? So I can write a handy little equation here. I got x plus my other x plus 25 has to equal 180 altogether, okay? So that's two x's plus a 25 equals 180. So if I take away my 25 over here, and so now that means I'm taking 155 and dividing it by 2. And I get 77.5 degrees. So each of those angles there has to be 77.5 degrees. All right, so we have our two little triangle rules so far. See if we add to these. Got triangles, angles add up to 180, and then isosceles, triangles, angles are congruent. All right, here's our last one. So this one we don't have any measurements. But notice what's important is that all three sides are equivalent. So that makes an equilateral triangle. So if an equilateral triangle, much like an isosceles triangle where the bottom two angles are equal, this one, all three are going to be the same. Well, if all three are the same, x plus x plus x, and it has to equal 180, because it's a triangle, that means all three x's equal 180. And if I divide 180 by 3, I get that x is 60. Now, x will have to be 60 for every equilateral triangle ever. Otherwise, it's not equilateral triangle. It's the only way for it to add up to 180 and for all three to be the same, okay? So, adding to my little list here, if it's an equilateral triangle, the angles equal 60, no matter what, okay? As soon as you know it's equilateral, they're all 60. So those are our three rules that are going to be important for triangles for you to remember, okay? Leave that there. And we'll do some practice. All right, so try this one. Here, let me erase the little black line so it's blocking part of it. All right, so use our information that we know to find the missing parts of the triangles. It's going to be important to be able to classify them because some of these rules, like the isosceles rule and the equilateral, only apply for those, okay? So go ahead and pause it, try this, and then hit play to check your answers. All right, this first one we know we got 80 and we got 50. So that's 130 altogether so far. So that means I need another 50, okay? So apparently this was isosceles because those two are the same if these two are the same. Over here we got 70. We got these two sides are the same. So if those two sides are the same, we go down the legs. These base angles have to be the same, okay? So 70, so that means it's 110 left over. If I split up 110, I get 55 for each of these. And then my last one, I got 36.5, I got this is 90. If I take away 90 from the 180, I'm left with 90. And then 90 minus 36.5, 53.5 for this angle over here. Okay. So for these ones, we didn't have to use the equilateral rule, but we used the isosceles rule, and then just obviously that they add up to 180. All right, I'm going to erase our little rules so you can see this. All right, so this one we don't have any actual measurements, but we have variables for all of them. We know that 3x plus 2x plus 4x, if it's a triangle, has to equal 180. It's a triangle, they add to 180 degrees. So 3 plus 2 plus 4 is 9x's all together equals 180. If I divide by 9, I get x is 20. So x is 20, but we want to find the measure of all the angles. So 3x's would be 60 degrees, 3 times 20. This would be 40, this would be 80. And if I double check my math, all of those add up to 180, so that works, okay? All right, go ahead and pause it, try this one on your own, and then hit play to check your work. If you are a little stuck, let's do this first part together. Hopefully you notice that these are isosceles. And remember, if you go down the legs, these two base angles have to be the same. So if this is 2x, this is also 2x. Okay, so that was a little hidden part that you had to figure out. Okay, now it's exactly like the other problem we just did. So 2x plus 2x plus x plus 20 equals 180 altogether. Okay, so then if I combine my like terms, 2x, 4x, and that's 5x altogether, plus 20 equals 180. Take the 20. Get 160 equals 5x. X equals 32. So remember, that's not your final answer. 32 plus 20 is 52. And 32 times 2 is 64. And again, 64. And if I add these all up, I get 180. And that's my final answer.